Okay, so very important, Bismillahirrahmanirrahim, that this force is the force on charge Q, right? Which this is the force that this is the force which this point charge experiences, right? This charge is this charge, not this charge. This charge, right? This charge is the actual charge that's giving and that's providing an electric field. Okay, so that is in newtons, that is in coulombs. Therefore, if you use this formula, the unit for electric field strength is going to be newtons per coulomb. Okay, newton per coulomb, or you can say newton per coulomb like that also. Then in the second, okay, let's do an example of this quickly. So here they say that charge B, so they say charge B experiences a force of 2 newtons due to charge A. Okay, so here they say that you have A of positive 2 microcoulombs and we have B of negative 5 microcoulombs. Then they say charge B, so they say charge B experience a force of 2 newtons due to charge A. So because of charge A, B experiences a force of 2 newtons. Okay? Because of A. A is almost like the cause of it. Okay? So remember? Okay. Then they say determine the electric field strength. Determine the electric field strength at point B. So what is the electric field strength at B? Okay? So okay, so charge B experiences a force of 2 newtons, right, due to charge A. So because of charge A, B experiences a force of 2 newtons. Okay, what is the electric field strength? So if you got force, you want to use this formula. Electric field strength is force over the charge. So the force is 2 newtons. What charge are you going to use? So the charge that you use is, they're saying determine the electric field strength at point B. So if they say at B, right, at B, the electric field strength at B, you must use B's charge, not A's charge. Okay, so then you're going to say that's 5 times 10 to the negative 6. Remember, micro is 10 to the negative 6, and you don't include the sign here, Kanala. Okay, and that's important. Okay, and put that in the calculator. We get 2 over 5 times 10 to the negative 6, and that is about 400,000 newton per coulomb. Okay, and yeah, that's 400,000 newtons per coulomb. Okay. Okay. So P experiences a force of 2 newtons due to charge A. So due to charge A experiences a force of 2 newtons. The charge, what's the electric field at charge P? The electric field is the force over the charge of P. Okay, they say they want the electric field at P, and this is the electric field. Okay, then okay, okay. So that's very important to understand. And if you look at this here, right? If you look at B's electric field like that, okay. So B's electric field is negative, so negative goes inside, towards the inside. Okay, so if here was a charge here, for example, a small q there, for example, that q would move towards the right because it's attracted towards B. Okay, so therefore the direction of this electric field is to the right. Okay, because due to charge A it's almost like charge A is going to be attracted towards B. You understand? So the electric field strength is towards the right. You understand? And that's why the direction is towards the right. Okay. Okay, so that's very important. So also a way to test for the direction is, say for example, if there was a small charge like a positive test charge and you place it here, right, this charge would move towards B because that's positive and negative and positive will be attracted to the negative. So therefore this positive discharge would move towards the right. Therefore the electric field strength is to the right. Okay, another way to do electrical strength is this formula where E is equal to KQ over R squared. So if they give you the force, then you're obviously going to have to use, if you have the force and charge, you can use this formula. But if you have charge and the distance between the centers, so remember, this is electric field strength, Newton per Coulomb. This is the charge, the actual charge of the charge, and this is the distance, right, from the charge. So let's say this is the actual charge you're speaking about, okay, and let's say this is a point charge, a certain point in space, and let's say that's R, and they can ask you to calculate, and Q, let's say this is positive. Q, this charge creates an electric field, and at this point of charge, this point here, or this point charge, for example, will experience a field strength because of this charge. You understand? So if they give us the distance, right, and we have now this charge is this charge over here that gives off the electric field, okay, and R is the distance, R squared in meters. Okay, very important. So let's say, for example, they say determine the electric field strength. Determine the electric field strength at point P due to charge Q. So in this case, we have Q, right? Positive 3 microcoulomb. And we got P there, like a point charge. So they're asking us what is the electric field strength at point P due to this charge. So you see that we got charge, right? We got the charge. They gave us the distance, 5 millimeters. So R is equal to 5 times 10 to the negative 3 meters. Kanala, milli is times 10 to the negative 3. You must know that, Kanala. So if we have Q and R, the distance, we can use this formula to calculate it, right? K is a constant on your formula sheet, so that's 9 times 10 to the power 9. Q is 3 times 10 to the negative 6, because micro is 10 to the negative 6. And R is 5 times 10 to the negative 3. Remember, milli is 10 to the negative 3. Okay? And that is to the power of 2. Alright? Put that into your calculator. If you put that into your calculator, you get 1,08 times 10 to the 9 Newton per Coulomb. Okay? And in which direction will a positive point charge move? So do you see, if a positive point charge was placed here, because that's positive and it's positive, and positive charges repel, this charge will move to the right. I don't want to move away from this positive. So therefore, your answer is to the right. And that's the electric field strength at this point B. Okay? That's it. وآخر دعوانا أن الحمد لله رب العالمين.